Hello, welcome to Math Natives. Do you speak mathematics? If you do, welcome to home. If you don't, come and learn. So, what is our straight to the point lesson today? Today we are going to talk about fractional or rational exponents. Okay, they are also called radicals. So, before we dive into the concept, so let's talk about a few things that we learned so far about rule of exponents. If you haven't watched the video on the law of exponents, so all there are videos that are made about that. Uh, Please go and see those. So when we raise a number to a power of n, that means we multiply that number by itself n times, right? So here are a couple of laws that we already cover in past videos. So the product of powers, right? When we are multiplying exponents that have the same base, we just need to add the exponent. And if we are raising uh, an exponent to a power, that is equivalent to multiplying the exponent. So we are going to use some of these concepts to explain fractional or rational exponents. Okay. Now, fractional and rational exponents are not completely new to you. Okay, you were introduced to them. So when you say when remember um, what square root and cube root are. Okay, those are fractional exponents. But at the time, probably in seventh grade, if you took seventh grade, they told you that the square root of a number is another number such that if you multiply that number by itself, you get the number that is under the root, right? So, and we use this symbol that we call a radical symbol, okay, to symbolize the square root. So, square root of x equal y, that means that y times y is x, right? So, as a refresher, uh, we give you some examples such as square root of 4 is equal to 2 because 2 times 2 equal 4. Okay. And we told you that square root of um, 9 equal 3 because 3 times 3 equal 9. Okay. Similarly, we told you that square root of 16 is 4 because 4 times 4 is 16. Square root of 25 is 5 because 5 times 5 is 25. Okay, so we give you several examples, right? The same way we define that the cube root of a number is another number such that if you multiply that number by itself 1, 2, 3 times, you get the number that is under the cube root. And this is the cube root symbol right here, right? Cube root of m equal n means that if you multiply n by itself 3 times, you get m, right? As examples, we told you that a cube root of 8 is equal to 2 because 2 times 2 times 2 equal 8. We told you that the cube root of 27 is equal to 3 because 3 times 3 times 3 equal 27. Okay, we can go on and on, right? So cube root of 64, okay, is equal to 4 because you guessed it, 4 times 4 times 4 equals 64. Okay, so far this is what you know about square root and cube root, right? So now, how is this related to the topic we are learning today? Right. Now, let's go back to what we say an exponent is. Right. We told you that when we raise a number to a certain power, that means that it's the base. Okay, what is in the at the bottom we call that base multiply by itself. Okay, that many times, right? That many times. In this case, it's n times. So, for instance, if we raise 3 to the power 2, that means we are multiplying 3 by itself 2 times. And if we raise 3 to the power 3, that means we are multiplying 3 by itself 3 times, right? So the exponent tells you how many times the base is multiplied by itself. Now, the question is, what about rational exponents, right? That's today's topic. What about rational exponent? For instance, when I raise 3 to the power 1 half, does that mean I have to multiply 3 by itself a half of time? What does that even mean, right? So, notice that our issue right here is the fraction, right? Because when we have whole numbers uh, like 2 or 3, okay, we know exactly what to do. But when we have a fraction, we don't know what to do, right? So, how do we get rid of that fraction? How do we get rid of that fraction since that's our issue? For example, how do we get rid of this right here? So, we remember that one way to get rid of 1 half is to multiply it by 2. So, what rule help us multiply exponent? Okay, that's the power rule of exponents, right? And this is it. A to the power of n times m. We know that it will help us multiply n times m. So using that, if I want to get rid of so this 1 half, I just need to raise this to the power of 2. So meaning that 1 half square, which is 1 half, okay, times 2, which is 1, 2 over 2, because 1 half times 2 is the same as when you are multiplying a fraction by an integer, you just need to multiply the numerator, since the denominator for that integer is assumed to be over 1. So that would be 2 times 1 is 2 over 2, right? 1 times 2 is 2. So 2 divided by 2 is 1. So that is the same as 3 to the power 1 or 3. So basically, this number that we have to square okay, to get 3, we call this one a square root. So a square root of a number is a number that you need to square to get that number, right? So this 3 to the 1 half is nothing else but square root of 3, okay? So because when we square it, okay, guess what we get? We get 3, okay? So that's the definition of the square root that we talked about earlier, okay? The square root of number is a number such that if you multiply that number by itself, and multiplying that number by itself means what? That you have to do square root of 3, okay, times square root of 3. So square root of 3 times square root of 3 give us 3, right? Because that's exactly what this is right here. All right. So um, that what a square root is. How about cube root? Okay. Now, using the same uh, power rule, if we have, let's say, 4 raised to the power 1/3, okay, since the exponent is our issue, how do we get rid of these 3 right here? Okay, this fraction right here. The best way to get rid of that fraction is to multiply that 1/3 by 3. And this is the rule that helps us multiply exponent. So we are going to raise this 4 to the 1/3 to the power 3. Or we call it to cube it. If we cube, okay, it, that will give us what? 4 to the power 1/3. So the exponent multiply each other as the rule tell us. So times 3. And guess what? So 3 times 1 is 3. So that will give us a 4 to the 3 over 3, which is just 4. Now, we call this number that we have to cube to get to get 4, the cube root of 4. Okay? So, cube root of 4 is a number such that if you multiply it by itself 3 times, you get 4. So this number right here is what we call cube root of 4. And you write it as a cube root of 4. Okay? Because uh, if you multiply this number by itself 1 times, 2 times, 3 times, you get 4. Of course, we can use the product rule also to show these same values, but I think uh, the power rule is a more straightforward way to show it, right? Now, this is just an introduction, okay? Uh, there are several other roots other than square root and cube root, right? Um, for example, if we write this 7 right here, um, that would be this 7th root of 5, right? So guess how we can write that as a fraction, as a fractional exponent, okay? That means that's 5 to the power of 1 over 7, right? So um, the eighth root of 9 is the same as 9 to the power of 1 over 8. Now, so the general rule is that if we have a fractional exponent, let's say a to the power of 1 over n, this is equivalent to the nth root of a. Okay, so this right here, that's your root index. Okay, this is what we call the radical symbol. Radical symbol. This is the symbol. Okay, and what you have right here is called the radicand. The radicand. Okay, so we'll stop here for the introduction. Next video, we are going to talk about how we can manipulate fractional exponents. But I don't want this video to be long, so we'll stop here. I hope this will give you some sense of what rational exponents are. Have a good day.